Alright, today we're doing secant and cosecant, but I want to quick remind you guys about tangent and cotangent. One of the things that was an issue was that we were mixing up the period and the center for the cotangent. So for the tangent, let's remember, tangent of x always has a period of pi over e. And with tangent, you can guarantee, unless it's been shifted, that 0, 0 is going to be in the center there. So let's say I had a period of pi, then I know that I have to go half of that in both directions. So if I'm doing my dotted lines around my center of the tangent, that would be pi over 2. If my period was pi over 4, I still have to cut that in half, and for tangent I think of it going both ways. So you go half the period this way, half the period that way. And then we have this kind of shape going like this. For cotangent, it's a little different because the center is always going to be half of your period, and it's not always going to be at pi over 2. So there were some yesterday that they would get to pi over 2, and then they would adjust their period inwards to the center, which isn't going to help you. That's not the way you should think about it. What you should do is you should realize, unless there's been shifting, your vertical asymptotes should be at 0, and then you have to go a period over. So whatever pi over b is, whatever your period is, that's where your asymptotes are going to be. And then the cotangent will be in the middle of that, and the cotangent is vertically flipped over the x-axis. So hopefully that helps a little bit. What I also wanted to remind you, and this is important for today, is that tangent and cotangent are reciprocals. Remember that we have a couple different ways to do opposites. If I have cosine, I have a couple opposites. I have negative cosine, which is the flipped sign. I have 1 over cosine, which turns out to be secant of x. That is not the opposite, that is the reciprocal. And then I have cosine inverse of x. So I have these 3 different ways to look at the opposites. And today we're going to be focusing on this middle way. Okay, but tangent and cotangent, they are opposites, and I want you to see the relationship of their graphs that way. Okay, cotangent is the same as 1 over tangent. And so, if I graph my tangent real quick, this is a normal tangent without any transformations. I want to be able to relate this to my cotangent and why it is the way it is. Okay, this is 1 over tangent. Now that means whatever tangent is, if I do 1 divided by it, it actually turns out to be opposite in size. So when I say tangent is like 1, that is the only exception where when I do like tangent of pi over 4, I get 1. It's also going to be at pi over 4, 1 for cotangent. Okay? Now as you think about this, as I start going up this way, my tangent gets larger and larger and larger as it approaches the asymptote. Okay? Now for cotangent, that would mean I'm dividing by smaller or larger and larger things, which means that my fraction gets smaller and smaller. And so as it approaches this dotted line here on the cotangent, it would actually start approaching 0. Okay? And then when it gets to undefined, for tangent, you're actually dividing by 0, which is why there's a vertical asymptote. For cotangent, it just would be 0. Okay? And then remember that the tangent keeps going, so the zeros of the cotangent are lined up with the asymptotes of the tangent. And then if I go down here, on the left side here, you have a really, really big negative number, which means on the left side, we would start off with a really, really close to 0 number, and it would start to get closer and closer and closer to infinity as cotangent gets closer to 0. Okay. So I can color code these. The yellow here is related to the yellow that I highlighted on tangent. The green is related to the green I highlighted on the tangent. And so that's why we have this flipped thing happening with my cotangent. Okay, so basically whenever you have a 0 on the tangent, you're going to have an asymptote here. Whenever you have an asymptote, you're going to have a 0 on the cotangent. So this is important because when we do secant and cosecant, we're going to do the secant first. It's important to think about what the cosine would look like first, and then do the reciprocal. So, secant of x is the same as 1 over cosine of x, and what that means for a normal secant, I'm going to graph the 5 important points of a normal cosine. So cosine would have a period of 2 pi. And so, something to take away here is, the period of a secant or cosecant is the same. So we still have 2 pi over b. Alright, now cosine starts at the higher end of an amplitude, and then halfway it reaches the lower end of the amplitude, and then it returns by the end of the period. That means at halfway points we're going to have this 0. So secant is going to be a lot like the cotangent. You think about cosine, you think about where is it going to be zeros, because when I do 1 over cosine, that's going to be an asymptote. So what I'm finding here is that when cosine is 0, that's going to be at pi over 2 and 3 pi over 2. So you're always going to graph these important key points, and then you're going to think when 0, I know that 1 over 0 will be your undefined points. Now a normal cosine would kind of go like this. And so we think of it a lot like what we were doing with cotangent. And we think, alright, as I'm getting closer and closer to 0, the reciprocal should be getting closer and closer to infinity. So what happens here is the graph will get closer and closer to infinity that way. Same with the other side. This is going to be 1, but if we think about traveling backwards to 0 on a normal cosine, that would be traveling backwards to infinity in both directions. Okay, and then over here, you would have this same movement. And then you would have another blue line right there. Okay. Yeah, I'm just thinking because we have 2 pi here, we want to go another pi over 2 here, which would be, this would be 5 pi over 2. Yeah, and so right here what we have is 1 period. Okay, so again, when you do these, you're going to picture a normal cosine, graph the key points, but the way secant and cosecant will always go is they'll have these little, almost like parabola-looking things. Okay, so that was secant. Cosecant we can do really quickly then. Cosecant of x is the same as 1 over sine of x. So the plain old cosecant is going to have the sine as its basis. And sine, after 2 pi, will have gone up, have gone down, like that. So I'm going to draw my asymptotes. Asymptotes are always when the one it's based off of is 0. And then I'm going to draw in red the cosecant. Or actually, let me do it in green because I have cosecant there. So it's going to do this movement here. Okay, and this is 1 period again. Alright, and to be actually accurate, we wouldn't even want to have the curves of the sine. That would be the graph of the cosecant. And so you guys are going to then move on after you get used to this idea, and you are going to graph examples that look a lot like this. Of course, we're going to start doing some transformations. So the 2 outside, that means it's 2 times taller, and then the 4 on the inside is 1/4 as wide. Because remember, multiplying is stretches, and inside is always opposite of what you think. So, you think, if I was to be doing a cosine with those same transformations, I would do 2 pi all over 4 to figure out my period. My period here is pi over 2. So I'm going to mark pi over 2 here, and then we always chop the period up into 4 pieces for sine and cosine. There's pi over 4. There's also pi over 8 right here, and goodness, 3 pi over 8 right there. Okay, cosine would normally start at the amplitude, which would be 2 in this case in both directions. It would go down, and then it would return after 1 period. And then, those are the key points. Alright, so my secant is going to have vertical asymptotes whenever it's 0. So, there's 2, and I know that it will have another one out here if we continue the cosine, because another key point, it would have been right there if we continued. And 3 pi over 8, 4 pi over 8, that would have been 5 pi over 8. Okay, and then we can do the swoops. Okay, and we would have another swoop over here. This right here would be 1 period. The length of that should be pi over 2. And so you will always have one vertical asymptote in the center of like secant and cosecant to deal with. Okay, now one more example. Let's say that you had some shifts and transformations. So let's do negative cosecant of x over 2 minus pi over 8 plus 1. Alright, the transformations, first of all, we got to do 1/2 in the front here. Factor out that 1/2 so it's x minus pi over 4 plus 1. So we have a vertical flip over the x-axis. The period is going to be expanded 2 times. It's going to be shifted to the right pi over 4 and then up 1. So when you have shifts, I strongly recommend you graph it without the vertical and horizontal shifts, and then you make your final product on a different graph. It'll be easier. So the key points for cosecant, you're going to go with sine to think about that. And it's going to be a negative sign. The period is going to be 2 pi over 1/2, which turns out to be 4 pi, so twice as wide. And so I'm going to write 4 pi over here. This will be 2 pi. And negative cosine starts going down, then it goes up. And the amplitude is going to be 1 in both directions. Alright, and so I know that my asymptotes are going to be whenever it's 0. So my graph without the shifts is going to, it's going to look like this. And that's 1 full period without shifts. So now we need to move on to our final product. What I do first is shift the vertical asymptotes, and then I shift the key points with that. So if I have to move over to the right pi over 4, okay, my first asymptote is going to be over at pi over 4. And by the way, on a test or quiz when you're sketching this, you would want to include the pi over 4 note so people know that you're talking about that particular spot. Then 2 pi over 1 plus pi over 4. I'm guessing, well, I'm trying to think fractions in my head. Boy, it's early. So we want the same thing, so that'd be 9 pi over 4. Okay, and then just make sure that these key points are shifted correctly halfway between. So if it's a plus 1, when it was down 1 before, it should be at 0. This one should be up at 2. And so you would have this shape, and you would have this shape. I'm running out of time on my recording software, but you would want to include the location of these. Make sure you note where the x value is. Just make sure you're pointing out important numbers and important points.